So, should I start?
Yes. This whole recording is started.
Right. Hello, everyone. Good afternoon. I'm Sajal Devnath, a solution architect with VMware's team, customer success team. Today, I'm going to present VSAN Overview. Now, when I say overview, I'm going to cover certain areas of VSAN technicalities of it. Right? So, today's agenda is just the overview and the important terms that are related to VSAN that you should know, how it works, how simple it is to handle VSAN, to configure VSAN, few advanced use cases, and then what's new in VSAN 6.5 covering that. Though we have VSAN 6.6 released 2 days back, but in this session, I'm going to cover most of 6.5 till 6.5, right? So, powered by VMware VSAN and vSphere. Before I go ahead and talk about VSAN is a hyper-converged architecture so it is software-defined storage, right? So when you say software-defined storage, that means the storage is defined not in the physical environment. The storage capabilities are defined in the software portion of it, right? And it is converged, when we say hyper-converged, because it's inside the host. So it runs inside the kernel of the hypervisor, right? You don't need a separate external storage for configuring VSAN. Actually, it utilizes the internal disks of the VSAN. So it runs on any standard x86 server. So whatever server on which a vSphere can run, VSAN obviously can run there, because VSAN is only the modules in vSphere hypervisor. It pools ultimately hard disk drives and SSDs, solid state devices, into a shared data store, delivers enterprise grade scale and performance. It's managed through per VM storage policies. That is why it is storage defined, software defined storage, and it's deeply integrated into the VMware stack. So you take the other different components of VMware products, they are integrated with VSAN. The use cases, typical use cases, you can run business critical applications, virtual desktops. VDIs can really take help of VSAN. You can utilize it in the test dev environment, staging, robo environment, management component you can run on top of it. BCDR is one use case of that, and you can run it in even DMZ, where you don't want to deploy the traditional SAN storage. You can go ahead and simply, because when you talk about this virtualized environment, let's think about that. In a traditional way, we have rack server or blade server. The local disks, we don't prefer to put anything in the local disks. We don't want to use these local disks, because that defeats the purpose of virtualization. So when you have shared storage, you put the virtual machine files or the things in the shared storage, so that there is no dependency on the end servers. If the server goes down, still the virtual machines are available to you. So in a rack environment, say if a single server has say 1 terabyte of local disk, ultimately you are not utilizing that space. You are just simply putting say ISO files or something else, but not the typical virtual machines. They are never put into the local storage. That's the best practice. So essentially, if you have say a 6-node cluster, you are wasting 6 terabyte of space. So with VSAN, we can actually utilize that local storage, which is a cheap storage, which will provide you lower TCO, and it's obviously local to the server. So it would be preferable, because your data does not travel over the network to a SAN storage or say ISCSI or NAS storage. The first thing is you are utilizing the local storage. So wherever use cases like say robo cases, remote office, branch office cases, you can't deploy a storage. You can simply utilize the local disks and present as shared storage. That's a very good use case. VDI environment, you utilize the local storage, you apply the policies according to whatever you want, and then consume the storage. So these are the typical use cases of VSAN. And it can leverage the next generation hardware, the latest hardware that you have in the market. It leverages those, say from SSD to NVMe or NVDIMM, so memory modules, especially for cache tier or capacity tier. We will discuss about these later, but we can utilize the latest hardware that is available from the market, vendors like Intel or others, and utilize it in the VSAN environment. So, important terms related to VSAN. Before we go ahead and talk about VSAN, we need to understand certain things. The terms that are utilized or related to VSAN. First thing is disk group. Disk group, as the name suggests, it's a group of disks that is there in a physical host. Say a single host has 12 slots or disks, 300K disks, 300 GB disks. I can create a group, disk group of 6 each. So I can, in a single host, I can have 2 disk group of 6 hard disks each. Consumed capacity is the total capacity. When I configure a VSAN cluster, the total capacity used over the virtual machines, the replicas, or all the entire other things, other components, that entire consumed capacity is the consumed capacity of the entire cluster. The most important thing is VSAN is an object-based storage. It's not your typical block-based storage or file-based storage. It's an object. So whatever you see, it's an object storage in the VSAN concept, right? Virtual SAN data store. In a single cluster, I can have 64 different hosts, but the single data store would be created. Out of all the nodes, all the ESXi hosts, in a single cluster, there will be only a single data store. That is a virtual SAN or VSAN data store. You cannot have multiple data store in a single, multiple VSAN data store in a single host, right? That's a major concept that you will need to have. See, a host can have external storage from, say, SAN, NAS, ISCSI, and VSAN concurrently, but they can always have a single, or say they can be part of a single VSAN cluster. Virtual machine compliance status. So, since it's a policy-based environment, a policy is applied against each and every virtual machine. And the virtual machines, whether they are compliant with the policy or non-compliant, the status you will be able to see each and every time. Component state, each and every component of VSAN environment, they can be either in 2 states. A component in the sense hard disks or the other components, say SSDs or other components, they can be either degraded or absent. So degraded if they are permanently lost. So the cluster will consider that, okay, this particular disk or this particular component has been permanently lost, so it will recreate the entire environment. Or absent is, let's say, for example, you put a host into maintenance mode, or you are rebooting a host. That means it's absent for the time being. It will come back. So it will not recreate the environment or recreate the storage for that particular disk or whatever information that was there in that disk or that particular disk group. What it would do, it would wait for it to come back, and it will wait for 60 minutes. If it does not come back within 60 minutes, it would be termed as degraded. That was the component state. The other perspective is object state. So I create a virtual machine. So virtual machine disks are an object to VSAN. So the object can be healthy and unhealthy. So if more than 50% of the components of that particular object is available, it is termed as healthy. If it's less than 50% of the components are available, then it's unhealthy, right? There is something called witness disk. Witness, since it's a cluster environment, in a traditional cluster environment, it's a Microsoft cluster or any database cluster or say, for example, operating system level cluster, we always had a quorum. That means that if I have a 2-node cluster or 3-node cluster, if multiple nodes goes down, who is the master, whether the things are cluster is running fine or not, that is defined by quorum. Witness disk is something similar but not entirely equal to that, or say entirely equal to the quorum concept. Witness is something, say I create a virtual machine, and virtual machine components are distributed over multiple hosts. So witness are defined that if a split brain scenario comes, so virtual machine disks are replicated over 2 different hosts, and since there are 2 hosts, if a split brain scenario comes, so from which host the files or actual data would be served, how to decide that? That's where the witness comes. So witness is defined in the third host. So witness disk, it's a metadata, it just contains metadata and 2 MB in size. So it's placed in the third host. Now between these 2 nodes which has the actual data, whoever contacts the witness first, that means he has 2 votes, his own vote and the witness vote. So it has the majority, and the data would be served from this particular node which has contacted the witness node. So that is the purpose of witness. A particular virtual machine may or may not have witness, or they even have multiple nodes depending on the stripe that I'm configuring. And the last term that you need to know is storage policy based management, or SPBM. So whatever management that I do here in vSAN is always based on policies. I define the policies first, attach the policies to a particular virtual machine, and likewise the virtual machine is handled according to the policies. So this is entirely a policy-based environment. It's not a traditional environment where you configure the RAID first, and say if a LUN is in RAID 5, so whatever you put in that particular LUN, say it's a 5 terabyte of LUN, or say 2 terabyte of LUN, so whatever virtual machines that you put there, all of them have RAID 5 configured underneath. It's not like that. It's per virtual machine. So the policies are applied to the virtual machine. Even a single virtual machine can have multiple disks. I can apply a policy to a particular disk that it would have, say, RAID 1 configuration, and the second disk can be RAID 5 with the Erasure coding. So I can even do that. That's the flexibility, and that's the beauty of vSAN, right? So whenever I configure a virtual machine and put that virtual machine in the vSAN node, it creates certain objects, and the different objects are, it creates VM home namespace. Home namespace is, it just contains the configuration file, say VMX file, it has a log files, NVRAM, VMSD, log, hlog, those configuration files are there. And then the VMDK files. So each of them are different objects. So VMDK file is a different object than home namespace. So VMDK, this particular object actually contains the data. It's -flat.vmdk. So in any typical data store concept, in vSphere concept, ESXi concept, we know that when you create a VMDK, it has 2 different parts, 2 different files. One is .vmdk, which actually contains the configuration of the particular disk, and then there is flat.vmdk, which has the data of that actual data. It contains the data of that particular disk. So for each and every disk that you configure in a virtual machine, separate object is created. For the flat.vmdk, the configuration would be still there, but the flat.vmdk file would be a separate object. Similarly, a swap object, .vswap. So whenever a virtual machine is created, there's a swap file that is created, right? The size of the swap file is equal to the memory minus the reservation. So if I create a virtual machine with, say, 16 GB of memory, the moment I power on the virtual machines and there is no reservation that I have configured, there will be a swap file of 16 GB in size. That is a separate object here in vSAN, right? By default, it would be RAID 1. There is no separate configuration for swap file. So if I have 100 virtual machines with 8 GB each, that means 800 GB of swap file would be created with RAID 1. That would be 1.6 terabyte. So you need to consider those configurations when you actually design or size the vSAN data store. And then for each and every snapshot, in the delta files, the actual data files, that will be separate object into the vSAN data store. and the memory. When you take a snapshot, if you selected that, okay, take the snapshot of the memory as well, then the VMM files are a separate object. So these different objects are related to a single virtual machine. So when I create a virtual machine, put in the VSAN, so these are the different objects, and then there are different components as well. The component in the sense a single object, I create a virtual machine with a disk size of 1 terabyte. A single object can give 256 GB. So you could split it up into multiple components. So remember that these are very important. Probably I will repeat it at the end, but I will just mention it here that when you design a VSAN environment, keep that in mind, the configuration maximus. A single host can have 9,000 different components. So if I create a VMDK file of 2 terabyte, that means I'm creating 8 different components for the disk itself. And on top of that, there are different components, right? So you need to consider how many components I'm configuring in that, and the total components that can be possible in an entire cluster, right? So you may think that, okay, I'm creating only single virtual machine with, say, one disk, but at the back end, it's splitting it up. So your number of components are increasing. You need to consider that when you design for your environment. A few things, probably we will go ahead and discuss about these in details, and you can find this in configuration maxima as well. A number of failures to tolerate, number of disk stripes. I will come back to this later. So let's first discuss how it all works, how it works. So the first thing is VSAN data store is an object store. I have already mentioned that, and I will stress it here that VSAN is object storage. Each object has multiple components, right? So this is to allow for availability and performance requirement. For example, I have created a VMDK and I said I want it as a RAID 1. So there will be two different components will be mentioned, two different objects will be maintained on different hosts. Two different mirror copies, and they are RAID 0, underlying RAID 0 in a single host, and say then on top of that I can say create stripe. So I can stripe the data. So whenever I stripe the data, I write the data across different multiple hard disks, right? So when I read them, obviously my performance would be improved, write performance and the read performance would be improved. So this from this structure you can see that I'm creating a RAID 1, so individually at the individual level it's just RAID 0, which is simple striping, and I'm selecting stripe width as 2 here. So there are two stripes, stripe A and stripe B. When I replicate it and mirror it, on the other side it's also stripe A1, stripe 2A and 2B. And the third node hosts the witness. So typically till 6.2, to configure a VSAN cluster, you need to have at least minimum requirement was 3 nodes. With 6.2 onward, there is an option where you can configure 2-node cluster, but then you need to give another node or another location as a witness VSXi host, a witness node. So typical environment 3-node cluster, witness is always placed on the 3rd node, right? The structure of VSAN storage. Thing is, I say it's an enterprise grade storage. How can I provide the performance that I get from an enterprise storage? So the performance is not coming from the hard disk drives like SATA disks or SAS disks or NLSAS disks. The main requirement, the major requirement that I need to have a flash disk. It may be SSD, it may be NVRAM. So NVMe or say PCIe based or SATA based SSD, but I need to have a SSD. This SSD is what is giving me performance. So this typically vast majority of reads and writes are taking writes are always happening on this SSD. Say if I have a 10 GB, say for example 10 GB SSD. 30% of that is reserved for write, 70% of that is reserved for read operation. So whenever a write comes, it is always written on the SSD. It never ever a direct write goes to the backend storage or back in say hard HDD, it always comes to the SSD. So the SSD writes are definitely much faster than whatever you have in HDD. And the reads are also happening from SSD. It caches the reads. 70% of the SSD is reserved for the read operation. If there is a miss, then only it goes to the backend HDD to fetch the data. And there also it pre-fetches. So say for example your file system, the virtual machine file system is 4 KB in size. So 4 KB chunk, so it reads in the 4 KB chunk, but when the data is read from the backend HDD, it is always done in the 1 MB size. It assumes that if you are reading for that 4 KB chunk, that means you are going to read something from in place as well, the other side. So the data that is fetched is 1 MB in size and placed in the SSD. And the SSD always holds the hot data, doesn't hold the cold data. Sometimes the read cache misses and the data comes from the HDD, it's stored in the SSD and 1 MB size, so that next time, say 4 KB block will be given from SSD and it will give you the performance. So this SSD gives you the performance comparable to our enterprise storage. So look, for example, think from SAN box, enterprise storage box, right? What gives you the performance? The backend disks, if you are using fiber channel disks or the fiber channel connector, the disks are SATA disks or SAS disks you are using, right? The typically SAS disks, the 15,000K or 10,000K or 7,200. 7,200 we do not use that much nowadays. Say 15K RPM disks. The same disks that you use in a SAN box, the same disks you use in a local disk as well. But the performance that you get is from the controller, storage controller, and the caching mechanism that you have. You have a very large quantity of caching mechanisms in the sandbox. That gives you the performance. So here, I'm just replicating the similar architecture in the per host node. I'm giving you a SSD which is working as a caching mechanism for you, and for the more capacity, I'm using the capacity disks, which is the HDDs. Right? So, but the beauty of this is, if I need say 2 TB of capacity per host, I can only apply 10% of that as SSD. SSD is costlier, right? So that means nearly 20 GB. 10% is 200 GB. 200. So 200 GB SSD that I'm using as a capacity tier, or say caching tier, right? So per host, that is only required. 10% is what would give you the best performance, or say that's what the sizing is when you design for that, right? Next comes the disk groups. So in a particular host, I can have multiple disk groups. Disk group is a collection of disks, right? So in a single host, I can have 5 disk group at most, and 1 to 7 capacity tier per disk group. That means I can have 1 to 7 disks or HDD per disk group. That means in a single host, I can have at most or max 35 capacity devices per host, right? And 1 flash device per disk group. So in a single host, I can have at max 5 flash devices and 5 different disk groups, right? Okay. So flash devices are again used for cache and read cache and write buffer. Disk groups cannot be created without a flash device, because I think disk group is a combination of SSD plus HDD, like cache tier and the capacity tier. And a single host can have 5 such disk groups. When you split, actually it splits across the disk groups that you do. That is a disk group. So when you configure VSAN, first you define a policy, then apply the policy to a existing or a new VM. So this is the most important part is existing VM. That means if a VM is already there, you can simply reattach another policy to it. You don't have to say shut it down or move it something. You don't have to do that. You can on the fly, you can attach another policy to it. You can have multiple policies defined to a single virtual machine as well, right? And it will show you whether it's compliant or not. Next question is number of failures to tolerate. So when you come to VSAN, we don't define any RAID level as such, like RAID 1 or RAID 0 or something. Later on we have RAID 5 or RAID 6, but is defined typically by number of failures to tolerate. If I say number of failures to tolerate is equals to 1, that means if one host goes down where the data was, I should still be able to get the thing. So that is its RAID 1. Typically, essentially it's RAID 1, or I would say RAID 1 plus 0, because the data that goes underlying is in the RAID 0 model. So if I say the number of failures to tolerate equals to 2, so n plus 1 copies, that means 3 copies will be maintained. That means at any point of time, if 2 failures happen, still it will tolerate, still you will get your data back. It will continue running. That's what the concept of failures to tolerate. The number of failures you can tolerate in your environment. Now, the number of hosts that is required equals to 2n plus 1. That means, say my FTT equals to 1, that means I need at least 3 hosts in that environment. Why so? Because if there are 3 hosts, then 2 copies of the data would be maintained and the third host would be used for witness. That is the reason it's 2n plus 1 host. So if I need to maintain FTT equals to 2, then I need 5 hosts. Right? That is the reason the kind of FTT that you require. So when you design, actually you need to keep in mind that how much my environment, how much FTT I need to give to each environment or each virtual machine, and the number of virtual machines hosts that would be required for that. Next concept is disk stripes per object. Right? The number of HDDs across which each replica of storage object is distributed. That is disk stripe. Like the similar way we had RAID 0 when we used to just stripe the data. Similarly, we say disk stripes or say stripe width. Right? So, for example, here the disk stripe width is equals to 2. And the number of failures to tolerate equals to 1. The example that you can see in the screen, right? There are 4 hosts and the virtual machine is RAID 1 because its FTT equals to 1. Failure to tolerate equals to 1. So that means I need to maintain a copy of the data in 2 different, entire copy in 2 different locations. And the data that is written is always RAID 0, as you can see. So the first data that is being written, that the green portion, the same stripe is happening within the single host, and the other copies are striped across the nodes. One point to note: VSAN never contains or maintains a data. That means it's not that if a virtual machine is maintained in a single host, the data will always go to that host. It may go to into other host as well. Clear? So there is no such concept as data locality, because you have, say, typically if you are going with all flash, you would go ahead with 10 gig. It's suggested that you have a 10 gig network, and think about that. Your network latency, if you have a 10 gig network, is typically into nanoseconds, right? But your disk write, SSD write, am I connected? Sid, am I connected?
Yes, I can hear you. Yes.
Right. That's fine. Okay. So the thing about that, SSD write, the fastest SSD write is still in milliseconds, right? So it doesn't really matter whether you write in the local disk or any SSD over the network, because nanosecond, which is your 10 gig network, it's in nanoseconds and in milliseconds in disk write. You add nanosecond width on top of millisecond, it's nearly negligible. So that is the reason I'm really not bothered where my data, the virtual machine data, is always going to the local disk or across the network. Now the advantage that I have here is, so since the virtual machine data can be from anywhere, the host that is serving that particular virtual machine, if it goes down, the data is somewhere else. I can simply start it from there. The other thing is, when I do a vMotion, actually I really do not need to copy that entire bulk amount of data over the network. think about this. If your data is always local to the host that is maintaining in VSAN environment at the back end, I say it's a distributed environment, but still at the back end, the way I am handling the data, if I always write in the local disk and I need to do a remotion, that means I need to move that entire 256 GB disk, the VMDK disk, I need to copy that entire data over the network. Is it really something that you want? Obviously no. But in this case, when my data is from the very beginning it's distributed over the network, if it remotions, I really don't need to copy the data over the network because the virtual machine has moved from one host to another host. That's the advantage of adopting this particular method. And the second thing is the stripes. As you can notice that one of the stripes, so one of the copies, all the stripes are going into the multiple hard disks into the single disk group, but the other copies, the stripes are across the ESXi hosts. That is one thing which is very important of the witness. When I said witness or the quorum disks, just try to understand that. Now it has a vote. And I say I need multiple witness disks, I may need multiple witness disks. In a traditional cluster, Microsoft cluster or in traditional cluster environment, I always needed a single quorum disk. There was never a multiple quorum disks, right? The cluster nodes are, say, even number of nodes, 4 nodes. I have another quorum host, the quorum disk, and say, let's forget about that. Let's take about 3 nodes are there. 1 node goes down, there are only 2 nodes. So 2 votes comes, or say 4, it's an equal case. So that's where the quorum is to be used to break even kind of scenario. Here, since my stripe data is not always kept in a single node, that means if I am doing a RAID 1 with striped void true, I am not always sure that all my data is available in a single host. 100% data is available in a single host. That data is distributed over multiple nodes. See, if I have 8-node cluster, it is distributed always over the multiple nodes. So I need to consider that if 50% of the data is available, more than 50% data, and to ensure I may need multiple witness disks. That is the reason. So that depending on the storage policy that you define, actually that defines how many witnesses you require in your environment. It may be 0 witnesses, or it may be 1 or more, right? The next thing is fault domain. So the first thing that we did is failures to tolerate. We can keep multiple copies of the data, say till 4, I can do a 4-way RAID 1, say 4-way mirroring. That means I can keep 4 different copies of the same data. When it comes, it goes into 4 different locations, and then I can stripe the data, and then I can define fault domains. Fault domains are the ones where I protect against rack failures, a single chassis failure or the rack failure or even the location failure. I can define in that way. That means, say I define, here you can see that 2 ESXi hosts each into the 1 rack, or say 1 chassis, and I define different fault domains, right? So 4 different fault domains are defined. So 1 rack fails, only 2 replicas are required, and witness across 3 failure domains. That's how I need to do it. So if one entire rack fails, still my data is available, right? That is where I create a fault domain, right? Now let's consider how an actual write happens, say in case of flash, all flash or hybrid. So VSAN, we can have all flash environment as well, or a hybrid environment. Till now we were discussing about a hybrid environment where we have one SSD as cache tier and HDDs as capacity tier. We can have all flash environment where I'm using a flash for cache and all say cache for flash for capacity tier as well. The difference how these two will be behaving, I'll be covering that shortly. But the thing is, I can have both the environment. I need more performance, I will go for all flash, right? So here, my VM is running on host 1, ESXi 01. Number of failures to tolerate is FTT equals to 1. So my one copy is kept on host 1 and the second copy is on host 3, ESXi 3, or the replica is on the 3. So now host, the gate inside the VM gives the write operation, right? So the owner of the virtual machine, remember, whatever ESXi host is running that virtual machine is owner of that virtual machine. So it clones the write operation and it sends the write operation parallel to the local and the ESXi 3 or whatever the data is, whatever the two hosts that the data is. So the write is always, persist operation is always in the flash. It's, as I mentioned earlier, that the write never goes directly to the hard disk drive, the HDD. It's always mentioned in the flash. Right? And then whenever it's written to flash to both the hosts, the acknowledgement is sent back to the host and owner waits for the acknowledgement ACK key for both the host, and when it comes, receives, and it says, yes, it's done. A write has been done from the virtual machine perspective. But VSAN later on commits the writes to the capacity tier. So whenever the write comes, just remember that whenever a write comes from a virtual machine, it's always written to that write buffer, the 30% write buffer that I have in the capacity cache tier, and the acknowledgement is sent back from there. So the VM says, okay, my write is completed, and the single write that I'm holding in the cache tier is never immediately flushed to the capacity tier. It's later on flushed. Right? It's a batch of write that happens. So that is the destaging that is happening. So when I'm destaging writes from flash to HDD in a hybrid environment, so data from committed writes, say accumulated, say 30% is full. So from different VM, from different virtual disks, all the writes has been accumulated in the cache tier. So elevator algorithms, certain algorithms are placed on that or run on that. So it writes the data back to HDD asynchronously. I will again stress it here. It is asynchronous write, not a synchronous write. And when I place the data, physical proximity it is considered and batches the data per HDD for improved performance. So that means, in HDD we know that it's a spinning disk. So I write in sector 1 and then I next write it goes happen into sector say 300, obviously it's not going to give you best performance. But if I have a batch of write which is happening sector 1, sector 7, sector 10, sector 17, it's going to give you better performance. So the data caching, it's actually another method of improving performance. So all the writes happening to the cache tier, then the elevator algorithm runs, it finds out what's the data, physical proximity of the data, it gets the data in that way, and then the writes are happening. So the data written is always in a physical proximal manner. It is improving your performance. So in a conservative way, overwrites are good. Conserve has HDD IO, and write buffers are flushed before discarding writes from HDD. That means so I'm writing to HDD. Obviously, HDD also has its write buffer. The entire buffer is flushed first. When every data is committed to HDD, then only the data is removed from HDD. Just one point to note here, since my write acknowledgement is coming back from HDD and I'm storing my data into HDD, so I would preferably have HDD where I have a battery power. That means if my host power goes off, the data would still be there in HDD, right? Sorry, HDD means SSD. That needs to be maintained. That is something that you should keep in mind. That if at any point of time the power goes off, SSD will still hold your data, right? So that is how an actual end-to-end write happens in a hybrid environment. How it happens in an all-flash? See, all-flash environment, one major difference from hybrid environment is that in all-flash environment, the cache tier, I still use a cache tier and capacity tier, but in cache tier, there is no read reservation. Reads are always from flash, from the capacity tier, because the capacity tiers are performing nearly similar to the cache tier, so I can always directly read from them. But the writes are always happening to the cache tier. So it's 100% writes are always going to your cache tier in all-flash environment, right? So writes from, so your committed writes, they're always coming to accumulating on your flash cache from different VMs virtual disks, and then in all flash, blocks that are written most often stay in write cache. That means your hot write data, that is always there. Cold data is not there, but if all flash blocks are infrequently accessed or cold, they are destaged to flash capacity tier. Just remember that, right? Any questions so far? Any chat window? Any questions? I'll just check for any question that's there in.
Yes, I don't see any question on the chat window. So guys, if anyone has a question, you can unmute yourself and ask this question to Sajal, or you can post it in the chat window.
Right, probably because at this stage we have already covered a lot. My most complex of the concepts we have covered, witness and then how read is write is happening. So if there is any question that you have, just let me know at this stage. Otherwise, I will go ahead and talk about a read that is happening. So far, everything clear? Okay.
Go ahead.
Now, how a read is happening, right? So we covered write. Now let's talk about a read. So guest issues a read on a virtual disk. Now the owner chooses the replica to read from, right? And it load balances across the replicas. It's not that there's a single location or it's a local replica. If there is any local replica, then it's not necessarily that local replica will serve. Depending on the load of the local or the local disks or the writes, it will choose a replica which has less load, right? And a block. Now, if you remember initially I talked about a single block that is always read, whether the block is, when the guest operating system is looking for 4K, the reads that is happening from the disks is always 1 MB in size. So that 1 MB is always read from a single replica. That means if you are, say, reading 100 MB of data, it's not necessarily that a single replica is serving your 100 MB. Say first 1 MB or the first 10 MB is served from one replica, the next 10 MB is from another replica. It's just load balances. So it reads in parallel. See, that improves your performance as well, right? So now a particular chosen replica from flash read cache, it is read. The read is served from that if it is present. If it is not, then it read miss happens or the cache miss happens. Then the data is read from HDD, and we are placing that data into the flash read cache. And I'm replacing the cold data obviously, and then returning the data to owner. So what is happening? Let's just repeat it again. The first thing is, the guest of the virtual machine issues a read command. Say it's a 10K of data it wants. So the owner of the virtual machine, the ESXi host, decides which replica is to choose the data from. And it's not necessarily the local replica. It can be from remote replica as well. And the block or the chunk that I'm reading, a chunk is always read from a single storage. So for example, a 1 MB block would be read from that replica. And then if it's there in the cache flash, so I will simply directly read it from there. If it's not there, it would be read from the HDD. The data would be placed in the cache, and the cold data would be flushed back to the disk, the HDD, and then from there it would be served to the virtual machine, right? That's how the read is done in a hybrid case. In an all-flash environment, say guest issues a read on virtual disk. Owner of the particular virtual machine chooses which replica to read from. It is again the same concept. And in the chosen replica, it's just simply flash cache, just write cache. So read data from the write cache. So somehow as we mentioned that in all-flash environment, the cache disk that I'm using is write cache. I'm not reading it from there. I'm not caching anything read from there. But if the read request that is there, that was written say just few minutes back, and it's still there in the cache, right cache. So it will be given from the right cache. It will not go from the other capacity tier. Understood, right? That means, say, I'm constantly updating my data. I just have written something, say a couple of seconds back to my desk, and now I want to read that data back. So that data that I have written back, it's still in the right cache. And since I'm reading the same data and it's there in the right cache, so I will read it from there. Then, if it's not there, then I will read it from the capacity tier. See, right? And then I would return back the data back to the owner, and owner serves it back to the VM. That's how a read is happening in the all-flash environment. Now, that is the entire thing. Now, in an all-flash environment, we know that the disks that SSDs we use, you have different categories, right? So probably high enterprise grade disk SSD I would be using for cache tier, and typical low cost SSDs I would be using for capacity tier. That's the difference that I can do. I will not have to always use typical high-end enterprise grade SSDs for all flash environment. For the capacity tier, so for capacity tier I would be using that enterprise class SSD, and then for the cache, for the cache tier I would be using enterprise grade, and for capacity tier I would be using lower TCO, lower cost SSDs. How simple it is. Although I would be showing a demo, but still showing it here because I cannot show you everything. My environment, live environment doesn't have everything here. But it's just selecting, like the way you enable HA in your environment. It's that simple to configure VSAN cluster in your environment. Manual or automatic disk claiming fault domains, you configure deduplication and compression enable or not. That's how it's configured. Day 0, 1, 2 operations, you configure that easy. There are health checks. You can monitor the performance. It will report you the capacity. It's everything there in the UI. The web client, it has everything. So you can see everything, how your environment is performing, what is happening in the environment. You can monitor everything from there. So when I do a health check, it has been introduced in 6.0. Particular tool that it limits check, you can do a HCl check, physical disk health, network health, stretch cluster health. That kind of health it checks and gives you the report. Proactive health check, you can actually go ahead and do some proactive health check. Right? You can create a virtual machine to see whether it's running particularly fine or not. Right? Performance service, it would tell you that how it is performing, how the backend is performing, whether there is single point of failure or not. Simplified metrics for the front end, for the backend, all is visible from the performance service screen. The capacity report, it would show you that which percentage is, which say swap is utilizing how much, virtual disk is utilizing how much, that kind of information that you will get from the capacity report. And there is alerting mechanism. More than 70 plus VSAN alerts, health alarms are available. And you can alert via SNMP, SMTP. That means the moment it has, the alert is generated, you can do some tasks. It can get some alert into, say, FreeDocs, vRealize, or it can send you an email as well, right? So all those kind of alerting is available in your environment. Right? As you can see, that I can define my say alarm. I can define my own alerts as well. Right? I can monitor the host and particular event that is happening. Say trigger if I'm defining that, okay, this is a particular error that is happening. So I want to get an alert, and for that alert I want to get a notification email. Now, whenever it happens, I will get a notification email, right? You can refer to the API documentation for more information on alerting. I can integrate with vRealize operations. See, I have virtual SAN troubleshooting by default. I install the management pack, and I get all these dashboards out of the box. It tells me what it is when it's running out of disk space or something is happening, some problem is there. I can go ahead and troubleshoot the way I do it for other environment. The similar way I can do it for VSAN environment as well. In login side, it also has a VSAN awareness. I can have special dashboard. It actually has special dashboards for VSAN. It tells you like the details of what the events that has occurred. I can go ahead and troubleshoot what happened in my environment. So that's all you need to do is go ahead and utilize those packs in vRealize operations and login side, which will give you the details of the errors or the issues that is happening in the VSAN environment. Right? Now, typical use cases, advanced use cases, I would say stretched cluster. So a single VSAN cluster split across two sites, and each site is a fault domain. What do I get there? So site level protection with zero data loss. Since I'm creating a fault domain, so whenever I write a data, that data is written between two different fault domains. That means I'm writing, say, failure to tolerate, FTT equals to 1. One copy is here and another copy is in the second fault domain. So if my primary site goes down, my data from the secondary site is always there. There's a zero data loss that is there. And it's near instantaneous recovery, automated failover. Just keep that in mind that the expectation is 10 Gbps bandwidth, and for the data replication, I need to have less than 5 millisecond latency, right? For witness, I can have witness in a third site as well. That's the one beautiful thing. That means I have one primary site, second replicated site, and a third site as a witness location. So I will keep my witness VM there, and witness may be 200 millisecond RTT latency, and it can have 100 Mbps bandwidth. But the actual data replication, it needs to be less than 5 milliseconds. So that kind of stretched cluster I can configure with VSAN. It helps in disaster recovery. So replication between VSAN data stores enables RTO as low as 5 minutes. Right? You can integrate it with Site Recovery Manager and across the metro distance and replicate it across geo. You can typically do that kind of configuration with VSAN. Remote office, branch office, that kind of deployment is something that you can do. That is a typical use case of VSAN. Now, advanced features. You can have deduplication and compression for space efficiency. It needs to be all flash environment, but anyways, VSAN environment is, I configure FTT equals to 1 or say 2. That means 3 different copies. I have a single virtual machine of 100 GB. That means I'm recording 300 GBs for a single data. Obviously, I'm utilizing much more data or much more space. I want to save space. How do I do that? So I can comply or I can apply deduplication and compression for space efficiency. What it does is nearline deduplication. When the data is destaged to the capacity tier, then first it's deduped, and deduplication length is 4 KB deduplication, and then it's compressed. One thing is to keep in mind when I'm compressing. So if it says that okay, 4 KB block, if I can compress and the compressed size is less than 2 KB, then only it's compressed. Otherwise, it's not compressed. For the sake of doing it, it does not compress it. If and only if the data that I'm getting, say I can compress it less than 2 KB, from 4 KB to less than 2 KB, then only it will be compressed. Otherwise, it will not be compressed. But the data will be duplicated first and then compressed, and that happens at the destaging environment, not at the write at the hot write environment. When the write comes, it goes into cache tier. From cache tier, when the data is deduped to the capacity tier, then only the deduplications are destaged to the capacity tier, then only it's deduped and compressed. First deduplication happens and then the compression happens. To save space from 6.2 onwards, we have introduced RAID 5 inline erasure coding. So I can have RAID 5 configuration with distributed parity, distributed data. number of failures to tolerate equals to if it is 1, and failure tolerance method or capacity is RAID 5 that I'm seeking, then I need at least 3 plus 1 equals to 4 hosts. That is the minimum requirement. So RAID 5 with inline Erasure coding, I would need minimum 4 hosts. But instead of double the overhead, so when I say typical environment FTD equals to 1, which 100 GB, I require 100 GB, I would actually give 200 GB. Here 1.33 times of data space is required instead of 2x. So 20 GB will consume somewhere around 27 GB instead of 40 GB with RAID 5. Similarly, we can have RAID 6, right? It's a failure to tolerate, say for example 2. So failure tolerance method is RAID 6. Then I need 4 plus 2, 6 hosts minimum. And instead of triple the overhead, I'm just getting 1.5 times overhead. That means 50% space I'm saving. So 20 GB disks again with typical RAID 1, FTD equals to a RAID 1, we say failure to tolerate equals to 2. I would need 3 copies, 60 GB. Here it would consume only 60 GB or 30 GB with RAID 6 with inline Erasure coding. But again, these are all supported on all flash capacity only. Next, VSAN 6.5, we can have 2-node cluster. We had that earlier as well with a separate witness disk. But instead of connecting it over the network, I can directly connect these 2 nodes. That's the using crossover cable, I simply can connect 2 different nodes and I can have a VSAN cluster, right? That is the capability that we have introduced in 6.5. Major thing is ISCSI. So I can even use my VSAN store and export my VSAN the storage as ISCSI storage to third-party solutions. That's what I can do. So all core functionalities are still available because it's stored at the back end. So all core solution advantages of VSAN is available. On top of that, I am exporting it as ISCSI storage to other solutions. Right, the configuration is pretty easy. It's just simply web client. Through web client, I can configure that, and it supports all the latest hardware that I have in your environment, that they are available in the market. New PowerCLI support is introduced with 6.5, through which you can health check and remediate capacity and resync monitoring. You can do proactive testing, 2-node and stretch cluster support. All this you can do through PowerCLI. That means you can automate all those tasks in 6.5. Right? You can directly utilize VSAN for containers and CNA, cloud native applications, like for example Kubernetes, Swarm, Docker environment. You can configure VSAN as persistent Docker volume driver, use it with that. You can utilize it through vSphere integrated containers. Photon platform is integrated with this VSAN environment. So with 6.5, you can utilize directly VSAN for all these environments, right? So how you can do it? You can check for free assessment. The assessment is free. You can check your environment, whether your environment, how you can benefit how you can benefit from VSAN for your environment. You can go for the free assessment. You can check hands-on labs and different deployment options you can check. Where to go? These are all links where you can actually go ahead and learn more about VSAN. I wanted to show you these links. These are amazing information that is available. The first thing is go to Storage Hub. It's storage and availability technical documents. You would select the virtual SAN. It's storagehub.vmware.com. Click on virtual VMware VSAN. It has a use case, plan and design document, interoperability document, learn and evaluate operations and management. All these documents are available under that. Right? How it would be, say, network design guide. How you would design the network for VSAN environment. Right? Sizing guidelines. All the documents are available. So go to storagehub.vmware.com and explore these resources that's there. The second thing is VSAN assessment that I was talking about. It's a free assessment. You can actually run the assessment tool in your environment, and you can know that how VSAN will help your business, how to help your environment. So it's a free assessment. Go ahead and run that assessment for your environment. The second thing is VSAN ready nodes. Just if you can configure that, okay, which node you need to configure, so I just select the VSAN version, then define profiles, all flash platform or hybrid platform, and then select OEM and model, and then you get to see that which are the VSAN ready nodes that are available there. You can simply go ahead and procure those nodes, and you are good to go. Next, blogs. This is your hyperconverged infrastructure blog from VMware. You would get all the latest information from this particular environment. Like for example, VSAN 6.6 came 2 days back, but you have all the information related to it. VSAN 6.6 is really a good, or I would say biggest release till far. It has many new functionalities, which is, for example, data at rest encryption and all that functionality. You should really go ahead and check VSAN 6.6. Just follow these blogs, and then you have feature walkthrough. It would go ahead. It's featurewalkthrough.vmware.com. You can go ahead and try online, or simply click on, say, virtual SAN feature walkthrough. It will tell you what are the different features, how you can enable VSAN. This is really good information. You can learn a lot through these websites, through these documents, how you would go ahead and say, you're just enabling virtual SAN. It has step-by-step screenshots. You just simply go ahead and select it, and you can do it in your environment as well. So I will simply suggest go to featurewalkthrough.vmware.com, and so this was enabling VSAN. Then creating a storage policy. How you assign policies to a virtual machine. It actually shows you step by step how you can do different tasks on virtual SAN. Say for example, if I click on components, so go to VM storage policies, related objects. It shows you what are the components that's there, and then rule sets. So it would, I can tell you this much. If you go through featurewalkthrough.vmware.com, you would learn about at least how to administer VSAN in your environment. Next, what's new with VSAN 6.5? This is hands-on lab. You can go there, launch it, try it yourself in those VMware hands-on labs. Simply go ahead and try these things. If you are a video person, go to YouTube channel. You have a separate VSAN environment. Say within 3 minutes, what is a VSAN, and then there's a separate channel, and this channel altogether. VMware storage. You have a lot of videos on VSAN. Go ahead and go through them, and you would learn a lot about VSAN. But I would strongly suggest just go through feature walkthrough, do hands-on labs, and you would learn a lot about VSAN. Right? Now, coming back to a demo. So this is my environment. This is my lab environment. This is an all-flash environment that I have configured. So as I mentioned, configuring VSAN is just like you're enabling your high availability. So I will go there, select the cluster, go to configuration tab, and you have high availability. Similarly, you have virtual SAN. Right? So I click on edit. Here the option is turn on or turn off, and add disks to storage, automatic or manual. Manual, where you will have to actually add the host and then manually claim the disks. In automatic mode, it automatically senses and adds the disks in this environment, and that means if you add another host in the cluster, it automatically gets the host, that adds the disks from that host in the cluster as well. And then here, since I have all flash, I can enable my deduplication and compression, and then allow reduced redundancy. That means you can see, we agree that VSAN will be able to reduce the production level of the virtual machines. It can do that, whether you want to allow that or not. I can simply say select yes, okay, to go ahead and do that. That is enabled for my cluster. It tells my environment like what is the on-disk format version. So on-disk format version is 3.0. There is 1.0, 2.0, and 3.0. 1.0 is the old VSAN format file system L, and then this is VSAN file system 2.0 is without deduplication and all that functionalities. With 3.0 you have deduplication and all that functionalities, right? Here internet connectivity, you enable internet connectivity for checking the HCl hardware compatibility list. I did not configure ISCSI target service. I can simply configure it here. Simply select enable ISCSI target, select ISCSI network, give a separate VM kernel port group, give a network default port. You can select the CHAP authentication or multiple CHAP authentication model, and storage policy for the home object. Whatever storage object that you place into the ISCSI storage, what is the default policy that it would enable. So you can simply enable your ISCSI from here. It's that as simple as that. Now when I go to disk management, it would show me the details of the disk groups. So for example, ESXi 2, I see that it has a single disk group. Under that single disk group, I have two disks. One is cache tier and another is capacity tier. So 20% is the cache tier and the capacity tier is 100 GB and 20 GB. Similarly, I have a disk group here and ESXi 3. And on a single disk group, I have two disks again. Since I enabled deduplication and compression, it's just recreating the disk groups. That's the reason I am not able to see ESXi host disk group, because it's just recreating it. You can see that the task is going on here. It's just creating disk group on virtual SAN, add disks to virtual SAN in ESXi host. That's why I'm not able to see here. If I want to configure fault domain and stretch cluster, right now it's disabled. I can actually create a fault domain, the preferred fault domain and the secondary fault domain. I have 3 ESXi hosts. I can move the hosts between the domains, and I would configure 2 different fault domains, right? And then select a witness host. Say for example, if I go to this and then select a witness host, which host I need to configure as a witness, and claim disks for the witness host, and then ready to complete. It will typically configure a fault domain for me. It's that easy for me, configuring fault domains, right? Health and performance. So health services, I have enabled it. The version, health check interval, HCl database, it would check from latest hardware compatibility list. It would tell you that whether the compatibility is latest or not. You can generate support model to service request. I can see that the status object health is healthy, and then status object policy, stats of the object policy and all this stuff. I can see that the compliance status is compliant. These are overall health. ISCSI targets I have not configured, and initiator groups. Otherwise, I would be able to see ISCSI target and initiator group information from here as well. Coming back to monitoring, I go to performance. At the cluster level, I see virtual and multiple, virtual machine consumptions. What are the consumptions? So IOPS, throughput, latency, congestion, and outstanding I/O, if there is any. I can see all that information from this monitoring, and go to monitoring and performance. I can see all that information from here. Similarly, the backend, how the backend is performing. I can go ahead and check that from the backend performance, that what throughput it is providing me, what is the latency that I am facing, or if there is any congestion, if there is any outstanding I/O, all that information I can get from this performance monitoring tab. I can go to virtual SAN. There is a separate tab for virtual SAN, and here I can see the health, overall health. What are the different checks that I have done? See, I can see that the fast is limit, network and hardware compatibility, and the performance service cluster data physical disk. The checks are failed because I'm doing some tasks at the back end, right? It's just recreating it. So it did for one and then it's recreating. That's why it's at this particular moment the tasks failed. So I can select the overall disk health. I can see the details, and I can see whether what is the status of that. And you can always click on Ask VMware. It would give you a pop-up where it shows you the knowledge base, KB article, what it means, right? All that. So wherever you see that Ask VMware tab, you can go ahead and actually, ask VMware. And you can do a retest of all the capabilities. You can run a retest. It would show you that, it would run all the tests and tell you how the health is working. Click on the capacity tier, the capacity environment. Okay, just reload. Meanwhile, when it's loading, is there any question?
There is no question in the chat window.
Okay. So as I was showing, I go to monitor and then. So the task that I did is actually removing the disk group from each and every host, and then it's actually recreating the disk groups. Okay. So I click on the capacity tier, capacity tab, and it's actually not able to showcase a few of the things because it's just updating at the back end. Okay, so I can see that the total capacity is this much, used is this much, deduped and compressed compression overhead is this, free portion is this, right? And it would show you the deduplication and compression before, after, and all this stuff. Now here I can see that the virtual disks are taking this much of the storage space, home objects is this much, swap objects are taking this much, and file system overhead, and each and every information that I can see in this environment, I can see the capacity which is being utilized by what. Resyncing components, if there is any resyncing that is happening in your environment, say something failed and it's just resyncing the data, it will tell you that information, that resyncing what are the components and how many bytes are left, and expected time to finish that, to be the compliant environment again. What are the virtual objects? I can see that the single virtual object is there, and see the virtual object health is reduced because it's still working. The VSAN, I'm just recreating the disk groups and stuff, so that's why it says that it's reduced. Now, in that, I can see this particular virtual machine. It has the hard disk 1, the RAID 1. I had configured RAID 1. The component 1 is degraded, it is not found, object not found. It was stored in certain ESXi host for which the component is not being found, that's why it's degraded. The other components is active, witness is active, one component is active and another component is active. So between two components, one is degraded, one is active, and the witness is active, and they are hosted on which host. Like I can see one component is there in ESXi 3, one is another ESXi 1, and ESXi 2 is being recreated. So that's why it's a degraded status it's showing. And compliance failures, I can see what are the failures that is happening. Failure to tolerate equals to 1. And number of disk stripes per object is equals to 1 that I have selected here, right? I selected virtual tiny CentOS temp machine, and say I go to health, I say go to policies. I select the machine, I get to see that the policy that is there, and physical disk placement. So you select the virtual machine, go to monitoring policies, select the disk, you see the physical disk placement, where it is placed, which particular host the disks are there, right? So witness disk, I can see it's 2, and then component, one component that is reconfiguring is ESXi 1 and active is ESXi 3. Since it's still there, that's why one particular component is available, that's why I'm able to work on that, but its status is degraded, right? So that is how you enable the VSAN cluster, you monitor from different environment, but to utilize it, first you will go ahead and say storage policies, you define a storage policy. Say a new VSAN policy, right? And use common rules in the VM storage policy. Say for example, encryption and storage IO control if you want to use this. But then this is where you would define, select a provider. I select a provider VSAN. The moment you configure VSAN, it actually storage API utilizes the storage APIs and it presents itself as a storage provider to the vSphere environment. Now I add a rule, and I have the rules, say number of disk stripes per object. I can define it as 2 disk stripes. I add another rule, flash read cache reservation. So for this particular object, so whatever VMs that I apply this policy to, I apply this policy to say 10 virtual machines. For all this, I want to do a read cache reservation of 10%. So inside I have a flash disk of 20 GB, 10% of that is 2 GB. Also the read cache is 70%, that means 14 GB. Inside that 14 GB, 2% is 10% is reserved. That's 1.4 GB is reserved for read cache, right? The second thing is number of failures to tolerate, say 1. Failure tolerance method. Here I am defining the failure tolerance method. Remember, RAID 1 or RAID 5.6, right? Or RAID 1. IOPS limit for object. I can define the IOPS limit, say 100 IOPS for this particular object. I can disable the checksum. Force provisioning. Force provisioning is if it's not compliant, still I will force the provisioning. It will go ahead and provision. Object space reservation. This is where your thin provision, thick provisioning comes. Similar to thin provision, thick provision. By default, it's the amount of storage is required given. If you want to reserve it upfront, you can do 100% reservation. Say I want to reserve storage 100%. Right? That's what, and then you can add tags. So that is where you define the policies, and then you see whether it's capable or incompatible. So right now I can see that the policies that I have defined, I don't have any storage which is capable, compatible to it, right? So I can probably go back, remove certain things, and then I can see what are the, say, number of disk stripes per object equals to 1, and then I can check it out. See, now I can see my VSAN, virtual SAN capacity, it's compatible. I can go ahead and define this policy, right? Now I can, storage policy components, you can go ahead and check the different components, and then you can apply a virtual machine, this policy to a particular virtual machine, right? When you apply this policy to a particular virtual machine, it will be deployed into the virtual SAN, and then it will be compliant to this particular policy. This is how you configure VSAN and apply policies, define policies, and then apply the policies to the virtual machine so that it would be compliant to that. right? This is all I had for this particular particular session. I can see that default storage policy is this. I can actually go back to the policies and change the policies from there. Any questions? Any question on this?
No, so there's no question in the chat window. However, if anyone has a question, please go ahead and ask. This is the right forum to your questions to be addressed.
Okay, so if there are no further questions, so probably I will go ahead and close it. But before I do that, I wanted to showcase that, okay, this is a virtual machine. I go to policies and then I can change the policy, VM storage policy. And I mentioned in the beginning, right? If a virtual machine has multiple disks, I can apply policies, different policies to different disks. Like for example, here for this hard disk, I would apply new vSAN policy, whereas for the VM home, that VM home namespace, I will still apply the virtual and default storage policy. So if I had multiple hard disks, I can say, for example, where it would help me, I am deploying a database. So for the OS disk, I would apply different policy. For the database transaction logs, I will apply different policy, and so on. And since I can do a policy-based management, this is where depending on your compliance, depending on your striping that you want, depending on the failure level, FTT that you want, you can define different policies and stuff, right? So this is how you would take help of vSAN. Okay. Thank you for your time and the patience for going through it. Have a nice day.
Thanks.